Hello everyone, in this video I'm going to be dealing with exponential equations. Now if you're watching this video from South Africa, this is grade 9 work, but I encourage grade 10s and grade 11s to watch it as well. Right, I have 50 questions on exponential equations. I want to make sure that by the time I finish dealing with exponential equations, you no longer have problems on this type of equations. So today I'll try and move up to 25 questions, and then in the next video I'll move from 26 up to 50. Right, so let's get into it. Question 1, of course, we're solving for x. Question 1 says 2 to the power x plus 1 is equal to 4. Now, in order for us to solve this equation, we need to make sure that the base on the left is the same as the base on the right-hand side. So how do we change 4 to base 2? So let me show you how we do it. Right, so our answers. Number 1, 2 power x plus 1 is equal to 4. If you do this simple calculation on the side here, let's call it rough work. Break down 4 into factors, a product of its prime factors. 2 goes into 4 2 times. 2 goes into 2 once. How many 2's do we have here? We have 2 of them. So this can be written as 2 for x plus 1 is actually equal to 2 power 2. Because bases are the same, we can equate powers. We're going to say therefore x plus 1 is equal to 2. X plus 1 is equal to 2. Equate the powers when the bases are the same. And we solve by subtracting 1 from both sides. We get x is equal to 2 minus 1. Or you can transpose 1 to the other side. And what is your final value of x? 1. I'm going to leave the checking for you to do it. In other words, take the 1, put it back there and see if the left hand side is equal to the right hand side. Let's move quickly to question number 2. Number 2, we have 3 power x minus 1 equals 3. 3 power x minus 1 equals 3. That's number 2. So what do we have? We have 3 power x minus 1, and the whole of this is equal to 3. Notice something here. The base on the left is 3, and the base on the right is also 3. But we need to notice that 3 can also be written as 3 power 1. And because bases are the same, we can equate powers. This one here is equal to that one there, like so. Therefore, x minus 1 is actually equal to 1. Add 1 both sides, get x is equal to 1 plus 1. And what is your x? This tells you that x is actually equal to 2. Right, let's move on to number 3. Equation number 3 says 5 power 2x plus 1 equals 125. So 5 to the power 2x plus 1 is equal to 125. Now, so we can see that the smaller of the two bases, 125 and 5, is 5. Again, I'm going to break down the 125 to base 5 as follows. 125, that's my rough work. And obviously, I'm going to take 5. 5 into 125 is exactly 25. Take 5 again. 5 into 25 is exactly 5. Take 5 again. 5 into 5 is 1. So we are basically saying 125 is 5 to the power 1, 2, 3. So 5 power 2x plus 1 is equal to 5 power 3. Now the bases are the same. I can equate the powers. Therefore, 2x plus 1 is equal to 3. Subtract 1 from both sides, or take 1 to the other side. You're going to get 2x is equal to 3 minus 1, and the answer is 2. And if you divide both sides by 2, so this, let me move it up here. 2x equals 2. Divide by 2 both sides, you're going to get x equals 1. That is your final solution. When you divide 2x by 2, you get x. 2 into 2, you get 1. Right. Let's move on to question number 4. I told you we have 50 questions, but for today, we only need to deal with 25 if we can manage. Looking at the amount of time we have for this video. Now I'm moving on to question number 4. Question number 4 says here, 2 power x minus 2 equals 1 over 8. 2 power x minus 2 is equal to 1 over 8. At this stage, I have to remind you of what we call the negative exponent. Remember, if I have 1 over x, this can also be written as x power minus 1. So there's a power here, 1. And when this one goes up, the power 1 here becomes minus at the top. We can actually prove that this is equal to this. As follows, if I may do it quickly. 1 we know is x power 0 all over x power 1. Bases are the same. What do? We subtract powers. So this is going to be x equals 0 minus 1. And what is this? X power minus 1. So yes, this indeed is equal to that one there. That means I can actually rewrite this 1 over 8. 2. On the left hand side, I have 2 power x minus 2. On the right hand side, I have 8 power minus 1. Nice. So now I have 8 to work with. So what do? I come back here and I say, let me break the 8 down now to base 2. So what do? I say 2 into 8 is 4. 2 into 4 is 2. 2 into 2 is 1. So I know 8 is 2 to the power 1, 2, 3. So this changes to 2 power x minus 2 is equal to this number here, 8. You can write it like this. And then in the next step, 2 power x minus 2 changes to 8 alone is 2 power 3. There's a power outside. Using laws of exponents, remember, m power k power t here is equal to m power kt. You multiply the powers. So here we're going to do the same. So this is 2 power x minus 2 is equal to 2 power 3 times minus 1. And this gives us 2 power x minus 2 is equal to 2 power minus 3. Now we are fine because the bases are the same. We can now equate powers. Therefore, x minus 2, this one here, will be equal to minus 3. Take minus 2 to the other side. You're going to get x equals minus 3 plus 2. Remember, 2 is minus. On the other side, it must be plus. And so your final solution is x equals minus 1. If you take minus 3 plus 2, it will give you minus 1. Right. Let's move on to question number 5. Question number 5, it says here, it says 3 times 2 power x plus 1 is equal, minus 48 is equal to 0. So let's copy it down. Question number 5 says 3 times 2 power x plus 1 minus 48 is equal to 0. So what is the next step? The next step is to take this one to the other side. So this means 3 times 2 power x plus 1 is equal to 48. We need to isolate this one in our next step. So I have to divide both sides by 3. Must get rid of this 3 here. 3 times 2 power x plus 1 all over 3. This must be equal to 48 all over 3. These cancel here. And what I have 2 power x plus 1 is equal to 16. 48 divided by 3 is 16. Now I go back to my ladder method here, 16, and I break it down as follows. 2 into 16 is 8. I take 2 again. 2 into 8 is 4. I take 2 again. 2 into 4 is 2. I take 2 again. 2 into 2, 1. What is 16? It's 2 to the power 1, 2, 3, 4. So what do I have now? I have 2 power x plus 1 equals 2 power 4. I have 4 2's here. Same base, I equate powers. Therefore, x plus 1 is actually equal to 4. Take 1 to the other side. X equals 4 minus 1. And therefore, my final solution is x equals 3. That's it. Question number 5. Let's move on to question number 6. We have many questions, remember. So please pause this video if possible and attempt these questions, then get back to the video to just check what your solutions are. Number 6, we have over here 3 times 2 power x plus 1 plus 5 times 2 power x minus 2 equals 58. So 3 times 2 power x plus 1 plus 5 times 2 power x minus 2 equals 58. Now, what we do here is that because the coefficients here are different, we have to break this one down and also break that one down as follows. So this will be 3 times 2 power x times 2 power 1. Remember, 2 power x times 2 power 1, if you can simplify this, it will give you this one here. But we need this form that will lead us to the answer. Plus 5 times this one here, break it down also to 2 power x times 2 power minus 2 equals 58. Now there's something interesting here. The common factor, you can see it. Take it out, factorize it. 2 power x, open brackets. When you remove this one here, out of here, you're going to be remaining with 3 times 2. Plus, if you remove this one here, you remain with 5 times 2 power minus 2 is equal to 58. Now, at this stage, if you punch the whole of this into a calculator, it will give you a very nice number. So 2 power x, hopefully, let's check what this one is on your calculator, because we have many questions. I don't want to try and work this one out mentally. It's 2 times 3 is 6 plus 5 times 2 power minus 2. If you put this in brackets like this, there, 6 plus 5 times 2 power minus 2, press the equal button, is 29 over 4. So this is times 29 over 4 equals 58. Multiply by 4 throughout, this side and that side, you're going to get 2 power x times 29 over 4 times 4 equals 58 times 4. Obviously, the 4's cancel. On the left, you have 2 power x times 29 will be equal to 58 times 4. Now you need to isolate this one here by dividing throughout by 29. So our next step, 2 power x times 29 all over 29 is equal to 58 times 4 over 29. These cancel. 2 power x is equal to 29 into 58 is 2. 2 times 4 is 8. 2 times 4 is 8. And we know 8 is 2 power 3. Why? Because 8, if you break it down, it will be 2 into 8, 4. 2 into 4, 2. 2 into 2, 1. So how many 2's are there in 8? 3 of them. That means you have the same base here. You can equate the powers. Therefore, your value of x is actually equal to 3. Comes out just as nicely as that. We're moving on to question number 7. Now, question number 7 is 2 times 3 power x is equal to 3 times 2 power x. Right. Looks a little bit interesting. Number 7, we have 2 times 3 power x is equal to 3 times 2 power x. So what we do here is to either divide by this times that or this times that. So I'm going to choose to divide by this times that on both sides. Whenever you have this kind of a question where you see here, this number here has a power, there, this number has a power this side, that's the approach you take. So in the next step, I'm going to say 2 times 3 power x divided by 3 times, remember I told you, you divide by the product of these two or by the product of those two. So I chose to divide by the product of these two. So times 3 power x. This and that, divide both sides. What you do on one side, you do the same on the other side. Remember laws of equations. So here I have 3 times 2 power x all over 3 times 3 power x. Now the 3's here cancel. And here This cancels that. So what do I have on the left? 2 over 3. What do I have on the right? 2 power x over 3 power x. Now you must remember from laws of exponents, if I have a over b power n, the answer is a power n over b power n. That tells you that this expression here is this one. So you need that. So we can now move to 2 over 3 is equal to 2 over 3 everybody power x. Now if I may, 2 over 3 on the left power 1 is equal to, on the right, 2 over 3 power x. You can see the bases are the same, therefore I can equate powers. Therefore the power on the right is x and the power on the left is 1. There is your final solution. Right, let's move on to question number. I hope you saw this one here. It's very clearly done. But get back to this and try and divide both sides by the product of this and that. You'll find the same answer as x equal to 1. All right, question number 8. Question number 8, it says, number 8, it says 16 or x plus 1 is equal to 1/4. Now I have two problems here. The negative exponent on the right hand side, like I explained last time. So this one can be written as 4 to the power minus 1. But the 16 has to be broken down. Let's break it down. So 16, breaking it down, 2 into 16, 8. 2 into 8, 4. 2 into 4, 2. 2 into 2, 1. How many 2's are there in 16? 1, 2, 3, 4. All right. So this is 2 power 4. But remember that's 16 alone. But outside I have a power of x plus 1. And I'm going to put in brackets like that. So when there's power inside and power outside, what do? You multiply the powers. So this is 2 power 4 open brackets x plus 1. Fine. On the left, I'm okay. On the right hand side, remember 4 alone is 2 power 2. But there's a power of minus 1 at the top there, which I'm going to put in brackets like that. So let's expand the brackets then. 2 power 4x plus 4 on the left. On the right hand side, 2 power minus 2. Same base, what do you do with the powers? Equate them. So you're going to get 4x plus 4 is equal to minus 2. Transpose the 4 to the other side, or subtract 4 from both sides. You're going to get 4x is equal to minus 2 minus 4. What do you get on the left hand side? 4x is equal to minus 6. What do you do next? You're going to have to divide both sides by 4, and you get x is equal to minus 6 over 4, which simplifies to, remember, 2 goes there 3 times, there 2 times, so it's minus 3 over 2. Minus 3 over as your final solution. So that's question number 8. Let's move on to question number 9. Question number 9 over here, it says 5 times 2 power 1 minus x is minus 320 equals 0. Number 9 says 5 times 2 power 1 minus x minus 320 is equal to 0. Now, I have some work to do here. I'm going to take 320 to the other side. Remember, the idea is to isolate this term here. So my next step is 5 times 2 power 1 minus x is equal to the 320 on the other side. It will be positive 320. Next, I'm going to have to, I always say to my students, what is the inverse operation of multiplication? That should be division. So to get rid of this 5 here, we have to divide. So 5 times 2 power 1 minus x divided by 5, the answer will be equal to 320 divided by 5. These cancel. On the left hand side you have 2 power 1 minus x. On the right hand side you have 64. And if you do the simple trick that I've shown you in the previous examples, 32 to there 16 to there 8 to there 4 to there 2 to there 1. How many 2's are there in 64? 1, 2, 3, 4, 5, 6. All right. So what we have now is 2 power 1 minus x is equal to 2 power 6. Same base, we can equate the powers. Therefore, 1 minus x is equal to 6. 1 minus x equals 6. What do you do? Well, leave minus x on the left, take 1 to the other side. You're going to get 6 minus 1. Minus x equals 5. Divide by minus 1 both sides. Minus x over minus 1 equals 5 over minus 1. What do you have on the left-hand side? X equals minus 5 as your final solution. Right. Question number 9 done. Let's move to question number 10. Remember, we have a target of 25 to reach. Hopefully we can work within our time. Number 10, it's over here. It says 7 power x minus 5. 7 power x minus 5 minus 1 is equal to 0. Now, this is an interesting one because we have the 7 here, power x minus 5, and we have 1 here. Let's take 1 the other side. That would be our first or starting point. 7x power minus 5, x power minus 7 power x minus 5 equals 1. Now, remember the base is 7 on the left-hand side, and I'm going to take advantage of the fact that any number other than 0, power 0 is 1. So, what am I saying? 7 power x minus 5 equals 7 power 0. And I know I chose 7 because on the left my base is 7. If I had a base of 29 here, I would have said 29 power 0. And yes, any number power 0 is 1 as long as that number is not 0. Because 0 power 0 is indeterminate. So, what are we saying now? We're saying x minus 5 therefore equals 0. Because bases are the same, equate the powers. What is your x equal to? Take 5 the other side. 0 plus 5, the answer is 5. That is your question number 10. Let's move on to question number 11. Question number 11, here it is. Our target is 25. Hopefully we can manage, but let's try. We have 4 power x equals 1 over 64. That seems a little bit easier than what we've done. So let's go to number 11. I'm going to answer it here. We have 4 power x equals 1 over 64. We have already seen in the previous example that 64 is 2 power 6. So on the left hand side, I have 2 power 2, but there's power x outside. This one here, I can write it as 64 power minus 1. And this is 2 power 2x is equal to, remember 64, we said this is 2 power 6. In the previous example, we said 2 power 6. Let me show you. Here it is, 64. 64, we said the answer is 2 power 6 over here, because we did that little trick of ours on the edge there to get our solution. So that means I can write this as 2 power 6, but there's a power of minus 1 outside. So this gives me 2 power 2x equals 2 power minus 6, because minus 1 times 6 will be minus 6. Same base, I can equate the powers. 2x is equal to minus 6. Divide by 2 both sides, you're going to get x equals minus 3 as your final solution. Right, question 11 done. Let's move on to question number 12. What is question number 12 saying? Question number 12 is here. It says 3 power x plus 2 is equal to 1 over 729. Okay, so on the left we're fine. Number 12, 3 power x plus 2 is equal to 1 over 729. Again, the same trick. 3 power x plus 2 equals 729 power minus 1. Let's work on 729. When I look at 7, 2, and 9, I know 3 can divide in there. So 729, let's do this trick here. 3 into 7, 6, that's 2. Remainder 1. Into 12, 4. 3 into 9, 3. So 243. I can take 3 again. 3 into 24, that's 8. Into 3, that's 1. I can take 3 again. That's 27. Take 3 again. That's 9. Take 3 again. That's 3. Take 3 again. That's 1. How many 3s are there in 729? 1, 2, 3, 4, 5, 6. You may also verify this on your calculator, by saying 729 is equal to, and then shift, there's somewhere here it says fact, so you can factorize it. You'll see that on your calculator there it says 3 power 6. So that's another simple way of doing this story on the right hand side here, our rough work. So this is 3 power x plus 2 is equal to, this is 3 power 6. Remember, there's a power of minus 1 outside. So that tells us that we have 3 power x plus 2 is equal to 3 power minus 6. Now bases are the same. We can say therefore x plus 2 equals minus 6. And if you take 2 to the other side, you're going to get x equals minus 6 minus 2. What is your x equal to? Minus 6 minus 2 is minus 8 as your final solution there. Number 12 done. Let's move on to number 13. Number 13 says what? Number 13 says 3. Here it is. Number 13 says what? Here it is. 3 power 2 minus x equals 243. 3 power 2 minus x equals 243. We've already seen here from here 243. How many 3's are there in 243? To be 1, 2, 3, 4, 5. You can also do this trick here. 243 factorize again 3 power 5. Or you can do this trick. It's fine. So this is 3 power 2 minus x is equal to 3 power 5. Same base, therefore equate the powers. 2 minus x equals 5. Same base, equate the powers. That is equal to that. And what do we have? Leave minus x on the left. Take 2 to the other side. It will be 5 minus 2. Minus x is equal to 3. Multiply by minus 1 both sides. You're going to get x is equal to minus 3 as your final solution. Right, that's the end of question number 13. Let's move on to question number 14. Where is number 14? Here it is. 2 power x power 2 equals 128. That's number 14. Number 14, 2 power x, everybody, power 2 is equal to 128. Laws of exponents. There's a power inside and a power outside. The two powers must multiply. So this is 2 power x times 2 is 2x equals 128. Let's do our little ladder trick here. 128. Again, 2 goes there 64 times. Let's take 2 again, 32. 2 again, 16. 2 into 16, 8. 2 into 8, 4. Take 2 again, 2 into 4, 2. Take 2 again, there, 1. 128, how many 2's are there? 1, 2, 3, 4, 5, 6, 7. Is it true? 128 is equal to, factorize. Yes, 2 power 7. So that's 2 power 7. Same base, 2x is equal to 7. 2x equals 7. The power equals power as long as bases are the same. Let me also say it here that if powers are the same, you can also equate bases. So for example, if I had k power 5 is equal to 7 power 5, you can also say k equals 7 because the powers are the same. Take note of that. Next, we divide by 2 both sides and you get x equals 7 over 2 as your final solution. Let's get to 15. We're rushing. Let's see if we can get to question number 20 if possible. 7 power x is equal to 1 over 49. This should be easier to deal with. 7 power x is equal to 49 power minus 1. Remember what I've said in the previous examples. What is 49? Obviously 7 power 2. So this is 7 power x equals 7 power 2. But remember the power outside is minus 1. What do we do with the powers there? Multiply them. So 7 power x equals 7 power minus 2. Bases are the same. Therefore, x equals minus 2. Equate the powers. That should be equal to that. Right, 15 done. Let's move to number 16. Number 16 says 1 over 5 power x is equal to 125. That's number 16. How do we deal with this? Well, inside here, remember what I told you? You can also write as 5 power minus 1, but there's a power of x there. 125, let's do our ladder method here. 125, I'm going to use 5 here. 5 into 125, 25. 5 again, 5 into 25, 5. 5 again, 5 into 5, 1. How many 5s are there in 125? We have 1, 2, 3. So that's 5 power 3. On the left-hand side, if you simplify it, you're going to get 5 power minus 1 times x is minus x equals 5 power 3. Bases are the same. You can equate the powers. Minus x equals 3. Therefore, minus x equals 3. Multiply by minus 1 throughout. Minus x times minus 1 is x. 3 times minus 1 is minus 3. That's your final solution. Number 17. We have 0,2 power x plus 3. I'm going to slow down on this one because of that 0,2 there. 25. Now, when you have decimals like this, if you can't see that 0,2 is cannot actually be written as a proper fraction, just punch into your calculator, 0.2, press the equal button, 1 over 5. The calculator does the trick for you. So this is 1 over 5, everybody power x plus 3 equals 25 is actually 5 power 2. We know that because 5 times 5 is 25. So there are two 5s and 25, 5 power 2. This one here, it's 5 power minus 1. Remember, there's a power outside, so I must put brackets there, equals 5 power 2. Now, this power and power outside must multiply. So what am I having? Now I'm having 5 power minus x plus 3 equals 5 power 2. What do I do next? I have the same base, I can equate powers. So minus x plus 3 equals 2. Expand this up here. Minus x minus 3 equals 2. Take minus 3 the other side. Minus x equals 2 plus 3. What do you have? You have minus x equals 5. Multiply both sides by minus 1. You're going to get x equals minus 5. And that's your solution. Let's move to question number 18. We're almost there. We are going to stop on question number 20. And then we'll move on and complete the 50 questions in the other videos. So we're now moving on to question number 18. Number 18 says 8 power x is equal to 4 power x plus 2. Now, 8 is 2 power 3, but there's a power of x outside. 4 is 2 power 2, but there's a power of x plus 2 outside. Please take note of how I'm placing these the expression in the exponent in brackets. It's absolutely critical that you do that, otherwise you're going to mess the whole thing up. Right, let's expand, remove the brackets by multiplying the power inside and power outside by applying the law that says m power k power a is equal to m power ak. Right, so here it's going to be 2 power 3x is equal to 2 power 2 open bracket x plus 2. Let me expand it. 2 power 3x equals 2 power 2x plus 4. Remember, 2 times x is 2x, 2 times 2 is 4. Bases are the same. What do I do with the powers? Equate them. Therefore, 3x is equal to 2x plus 4. And transpose the 2x to the other side, you get 3x minus 2x is equal to 4. As I always say when I'm teaching this to the juniors, students in the lower classes, I always say 3 cars minus 2 cars. How many cars do you have left? Obviously, there will be 1 car left. So this is the final solution. All right, number 19. Hopefully we can do it. 1 over 4 to the power minus x. It's actually positive x plus 1 is equal to 16. So it says 1 over 4 over here. You can see it here, there. 1 over 4 power x plus 1, 1 over 4 power x plus 1 equals 16. So now, inside the brackets, remember what I taught you? This is 4 power minus 1. This is the power of x plus 1 outside. It must be in brackets. 16, well, 16, if we break it down, 2, 8, 2, 4, 2, 2, 2, 1. How many 2s are there in 16? 1, 2, 3, 4. 2 power 4. What is this 4 here? Well, 4 is, let's multiply that power and that, so that we have 4 power minus, open brackets, x plus 1, like so. But remember, 4 alone, I know someone is saying, why did you not express that in base 4? I prefer base 2 because it's easier to work with base 2. So this one here can be simplified to 2 power 2, but outside I have power of minus x minus 1. If you expand this bracket here, this is what you get, equals 2 power 4. And if you expand, you take, you multiply the power outside and power inside, you're going to get 2 power 2, open brackets, minus x minus 1 equals 2 power 4. Now I have the same base, I can equate the powers. So minus 2 times minus x minus 1 is equal to 4. This part here equals that part there. That equals that. Now I can divide both sides by 2. If I divide this side by 2, and I must divide that side by 2 also, what do I get? These 2's cancel. And on the left, I'm going to have minus x minus 1. On the right, what is 4 divided by 2? The answer is 2. If I transpose the minus 1 to the other side, or take minus 1 to the other side, I'm going to get minus x equals 2 plus 1. What is minus x equal to? 3. Multiply by minus 1 throughout, you're going to get x equals minus. This becomes positive if you multiply by minus 1. That becomes minus. So that is your final solution. That is question number 19 done. Let's move to number 20, where we're going to stop for today. Right, question number 20, here it is. It says 1 over 2 power minus x plus 1 is equal to 1 over 128. Now we have double trouble here. So on the left hand side, remember what I told you, 2 power minus 1, but there's a power of minus x plus 1 outside is equal to 128 power minus 1. I also told you that already. And on the left hand side, it's 2 power minus 1 times minus x plus 1. The power inside times power outside. What is 128? Well, if you do this, 64, 32, I'm dividing, 16, 8, 4, 2, 1. How many 2's are there in 128? 1, 2, 3, 4, 5, 6, 7. Is it true? Let's check. 128 is equal to, shift factorize. The answer is 2 power 7. Yes, correct. So 2 power 7, but there's a power of minus 1 outside. Put in brackets like so. Expand the left hand side. It will be 2 power positive x minus 1 times minus x positive x minus 1 times positive 1 minus 1 is equal to 2 power minus 7, because 7 times minus 1 is minus 7. Same base, I must equate powers. So therefore, x minus 1 equals minus 7. And therefore, x equals minus 7 plus 1. The minus 1 must go the other side. It will be plus. And so your x equals minus 6. Be careful here. Minus 7 plus 1 is minus 6, not minus 8. Please take note of that. Minus 7 plus 1 is minus 6. Why? Because minus 7 plus 1 is the same as 1 minus 7. You can clearly see that the answer must be minus 6. Minus 6 is our final solution. But we're going to stop here for today. In this video, we've been looking at exponential equations. We have 30 remaining, so maybe one more video. It's going to be a little bit longer, because the questions from here now, you can see the degree of difficulty is increasing as we move forward. So if you are new to this channel, please subscribe. Let's share these videos with other students. It's going to help us to grow this channel and give us the impetus as I say, or momentum to produce more videos. All right, I'll see you in the next video.